I am live. Okay, hello everyone. I am live. Okay, hello everyone. You know what? Let me just disable my screen a little bit for a bit. Okay, the contest will start in 2.5 minutes. So in case you're not familiar, it is a Blitz Cup format, which means there will be several problems, and the problems will be opened one by one. And there can be only one person, and this is 1v1 match, and there can be only one person to solve each problem. So first problem A will be open, which will be the easiest problem. And then I'll just quit Discord so that it won't disturb me. What am I about to say? Yeah, so first problem will be open. And then the first person to solve it will get the points. And then the next problem will be open after that. So yeah, there is only one problem open at any given point of time. And the fastest person to solve it gets the number of points, basically. And the points will gradually increase because like the order of the problems open will be ordered by difficulty, okay? So yeah, it will start in 1.5 minutes. I just took a cough syrup just now, and it's supposed to cause drowsiness, but hopefully I can stay alive for the next 40 minutes. 41.5 minutes, I should say. Okay, yeah, so I should be ready. My editor's on the right, my terminal's on the left. I will see problems on the left. Okay. Wish me luck, and I hope you get a nice show. I hope I can show you a nice round. And good luck for my opponent as well, DylanSmith. Round will start in half a minute. 10 seconds. Yeah, obviously I won't be able to read chat. Sorry about that. I will read chat after the contest is over. So yeah, feel free to send me any messages. I will read them after the round. just submit. Shit. Oh, there is no test cases. Did I get the points? Okay, nice. I need to remember to comment out that line if it's not multi-cases. That was close. I don't know how close it is, but like that was a silly mistake, and if I lost because of that, that was a bit silly. Problem B will open in 31 seconds. Okay. I guess I should explain what I did there during intermission. I'll do it after problem B is solved. Oh, come on. Don't. Come on, internet. Huh, okay. Oh, of course. That's it, right? Yeah, that should be correct. I shouldn't need the new line, right? Come on, submit, please. Okay, did I get it? Okay, I got it. Okay, I don't know why the connection, every time I submit, it's so slow. But okay, I got both problems. So far, so good. Okay, so problem A, basically, you know that, like, yeah, it's a classic math question where, like, if you want to know the value of a to the power of b mod 10, you can mod the b by 4 because, like, it repeats by 4. So, like, yeah, basically, if b can be a big number, just mod it by 4. And then for problem B there, I just do 1 and 2 and minus 1, 3, yeah. Oh shit, I forgot to open the problem, the code. Okay. Okay. Oh, I see. Oh, I see. Oh. Yeah, okay, just make it all long. Okay, so there is a wall here. I can't Oh, I see. So if they are on a different part of the GCD, one means one is the inner and one is the end. Okay, one is the end, so it should be mod n over g, something like that. Is it something like this? And then if a equals b, then yes, otherwise no. Wait, what? Wait, what? Why am I printing? What the fuck? Oh. That should be n m x. As x is 1, then n over g, n over g, n over g mod 2. Oh no, it's d5, sorry. Yep. Come on, come on. Please don't tell me I solved it. Okay. I think I got accepted and I solved it. Okay. Okay. Good. I got 3 problems in the back. That is good. So far so good, we are dominating. But the points for later problems are bigger. So there is still a very real possibility of a comeback. So I still need to be very careful. Oh, I see. Hmm. Okay. Wait, what is K? Oh, okay. Um. Yeah, that should be fine. Okay. Of course. Okay. We got the first four problems. I actually don't know what's the minimum number of points to guarantee victory. I don't remember the exact number of points distribution. It's like A to E enough? There can be 7 problems, right? If I remember correctly. So far I got 15 points. I don't remember what's the total number of points for E, F, and G though. Should I check quickly? That is only until E. Okay. It's okay, I don't have time. I don't have time to check the number of points. I guess I should have done it before the round starts. Okay, this won't be easy, unfortunately. Okay, so we need to give the largest. We want to maximize this, so the large number should be on the centroid, right? Something like that. The number of ones among all must be minimized. Okay. yeah, this will take a lot of time, which can be a good thing. Even if, yeah, I don't know. Like I don't think we will unlock the seventh problem because this problem will take a lot of time. But still, we can't assume that we already win. So I still need to continue solving. Okay, first we have to know what is the minimum number of ones. Should be equal to k, right? So in order to minimize the number of ones, I think we can greedily choose prime numbers. But can I just oh, these are prime numbers. Oh, okay. So that's convenient. I don't have to factorize it. I can't factorize it. So that means these m must go to these edges, these numbers must go to these edges, and oh, okay. And then the rest are ones, right? And then I greedily, okay. Can m be larger than n? It can, okay. I already have that one. Oh no, actually no. Okay. Okay. It's actually not as complicated as I thought. I mean, assuming this is AC. Okay. I might have sealed the round. I'm not 100% sure, so I still need to continue solving. Should we quickly check? Can you give me a round where like all of the 7 problems are open? Can't find it yet. 10 and 12. Okay, so the last 2 problems are 10 and 12 points. How many points do I get so far? 22. So yeah, maybe I have sealed the round, because the most you can get, the most my opponent can get is 22. But we still need to continue solving. Is this some ternary search shit? No, I guess I can greedy. Wait, how do I? Ah. Oh, I see. Yeah, okay, I can greedily adjust the one that has less number of elements. And then, okay. Okay. Wait, I want to test that. Does getting Y like that works? It works, right? Okay. Then we should decrement Y. We should decrement Y so that it goes, okay. Okay. Okay, minus that. CNTY equals to 0, CNTY plus CNTY. Y. Okay, there is an else here that I need to handle, and here as well. This is z minus x times CNTX, z minus x, CNTX, CNTZX, x, okay. Wait, but move can be 0, shit. Oh, dang. Fuck. This is annoying. Okay, so if k is small, some of that will move. duplicating code like this is never a good idea. Wait, what? You can't get rbegin, the pointer of rbegin. Okay, then I'll just do n, but decrementing it twice. 0. Very good. Oh, I guess I didn't. Wait, no. This k should be 0. Yep. Why did I press the refresh button after submitting? Did I submit? Oh, I did submit. Okay. Oh, it looks correct. Surprisingly, that was a very complicated code. I didn't expect it to pass first try. Wow. Okay. Wow. Okay, last problem. Yeah, I definitely sailed the round this time. Can I get a clean sweep? No, definitely not, right? I only have 3 minutes left. Never mind. But yeah. GG. GG. Let me see my YouTube chat from my phone. Okay, give me just 3 more minutes to at least try to solve G. And then I will try to give a bit of commentary of what I did and so on. Post-round analysis, basically. Oh, okay. Wait, what? Oh, I see. Oh, okay. I understand the problem, but there's no way I can solve it in 1 minute. Okay. How do you solve it? Oh, with a digit TP, right? Yeah, okay. Yeah, okay, I know how to solve this with the digit TP. Okay. Yeah, so basically, like the score of this is defined by the number of overlapping segments between consecutive characters, and then given um, oh, not consecutive. The next n. Oh, I see. Okay. Oh wait, it's not digit DP then, because I thought it's the consecutive one. Sorry, never mind. But yeah, should be some DP stuff. Okay, GG. I guess I can read my chat from here, right? Yep. Thanks for the GG. Hope you win. Thank you. Yeah, sorry, I didn't read the chat during the contest for obvious reasons. So yeah, I think I discussed A and B after I solved B, so we can skip that. And yeah, good game for my opponent, DylanSmith. Yeah, problem C. Yeah, so this involves GCD basically. You know that the lines like will coincides between the both layers. Every GCD of that. So like, no, the number of like walls, like permanent walls that is closed between like both layers are GCD, right? So let's, yeah, because the outer here is 6 and the inside is 4, the GCD is 2, so there will be like two long walls, right? And then yeah, it means basically like the inside, the long walls will be every like 4 divided by 2, and then the outer one will be every 6 divided by 2. And then yeah, basically like you figure out which layer it is. So there are basically like two layers here, not layer, like two segments. And if they're on the same segment, it means it's possible. Otherwise, it's not, right? Yeah, and you know like the segment, how many segments there are. So you know like, yeah, if it is on the outer layer, you know which segment it is by dividing the number of like, yeah, how many cells in each segment and so on, right? I feel like D is easier than C. D, because D is just purely simulation. C, at least you need to think about it, like think about it a little bit and figure out the GCD stuff. Yeah, but but D is just simulation. E, yeah, E is, I thought this will be long because I need integer factorization, and yeah, and it can get messy with factorization. There can be large primes and so on. Or rather, no, never mind. But yeah, I missed the fact that the given numbers are already prime, so it makes life easier. And yeah, basically just greedy, like there are n-1 edges. Let's say m equals to n-1 first, then we assign the heaviest prime, the largest prime to the edge with the most visited edges. You know, you can calculate how many times that edge will be visited by taking the product of both subtree sizes, right? That is cut on that edge. Yeah, so, and then you just greedily take the largest prime, assign it to the most visited edge, and so on, right? And if m is less than n-1, then you just add tailing ones, right? But if m is greater than n-1, then you can combine several primes by multiplying it, and you can greedily, the way you do this is you basically make the highest prime, make the largest number as large as possible. So you multiply the largest primes into one number and then assign it to the most visited edge, right? Yeah. And then this part is, yeah, this part is just data structure. Basically we want to greedily increase the minimum element or decrease the maximum element, and every time you do that, you check which one has more elements. So if the minimum elements has less elements, has less number of elements, then you increase that one, because that will save you operations, right? That will save you the number of operations, right? So yeah, so let's say the number is like 113. So you decrease 3 instead of like increasing 2 ones, right? So yeah, but then you just have data structure to like be able to like every time you increase numbers, like you increase all of them together, assuming like you have enough number of operations, and every time you increase them, you increase it all the way to the next minimum number, next minimum, right? So you use, by doing that, you reduce the number of elements by 1, right? Otherwise you get TLE if like k is so big and a is like 1 and 10 to the power of 9, then you only increase it 1 by 1, you get TLE, right? So yeah, you need to like do several operations together, but that's the idea. If you can do it naively, you greedily choose which one has the less number of elements, but you have to combine several operations together so that every time you do one operation, let's say, which is actually several number of operations, you like reduce the number of distinct elements by 1, something like that, right? Yeah, so that won't get you TLE, it will be ON, right? But yeah, the data structure is a bit messy, and like, yeah, the code is actually a bit messy because I have a lot of code duplication here. This part is for like reducing the maximum element, this part is for like increasing the minimum element. And then like I check whether like I can increase all of them, or like because k is not divisible, but k is not a multiple of the number of minimum elements, that it gets messy, right? I can increase some of them but not all of them, so like, yeah. But yeah, that's basically the idea. And yeah, thanks for tuning in. This means I will qualify to round 2, which I think I will face Dominator, right? Yeah, Dominator 069. I think they are C.11. I am C.50 something, I think. Yeah, so this is round of 64. So yeah, I think I'm C.54 and Dominator is C.11. So that will be a huge seed gap. So probably I'll get beaten. I don't know, we'll see. But yeah, well, at least I'm not out in the first round. That was a good match. Thanks for the round once again, DylanSmith. Yeah, I think that's all. I will end the stream now. Thanks all for tuning in, and yeah, see you in the next round. Bye everyone.